Hey guys, Mr. Mack here. I said I would give you some practice solutions here for 5.3 concurrent lines. And I know we did some of the first already, so skip ahead if you have already done this part and want help with the later part, but I'm just going to run through it real quick anyway. So find the center of the circle that circumscribes ABC. So we need to find the circumcenter. So that matches with circumscribe, circumcenter, and in order to find the circumcenters, we need the perpendicular bisectors. Okay, so let's take a look at AC here. Where's the perpendicular bisector? Well, first I have to find the midpoint. So I know the midpoint from -4, 0 to 0, 0 is -2, 0. And then I know this line is horizontal, so a perpendicular to a horizontal is a vertical line. So I'm going to do a vertical line through there. And it's a perpendicular bisector. Let's find the midpoint of B to C. That's going to be 0, 2. And I know that a vertical, this BC is vertical, so I need a horizontal line to be perpendicular. And then our last point, from A to B, I know I'm rising 4. So then if I take half of 4, I get 2. So I know this is my midpoint right here, right on the hypotenuse of this right triangle. And this slope is up 1 over 1, so the negative reciprocal will be -1 over 1. So I go down 1 over 1. And I see that all three perpendicular bisectors intersect at -2. So here's my circumcenter right here, is at -2, 2. And we could put a circle here. We could circumscribe a circle from that circumcenter right there. Okay. Number 2 is the same. I'll leave you to figure that one out. Find the midpoints, the perpendicular lines, and then the intersection where they all meet. And let's just run through these real quick. Are we looking these dashed segment ABs? Are they angle bisectors, altitudes, medians, or none, or perpendicular bisectors? So this one's going from the midpoint to the vertex. Well, that's how we define a median. This one's going, number 4, from the vertex to the opposite side, forming a 90. This is an altitude. Here we have 2 congruent angles. So therefore, this blue segment AB must be an angle bisector, because it splits this angle into 2 congruent angles. Here we have, this is congruent to this is congruent to this, no, this isn't. So nothing's happening here. Can't find any relationships. Let's say none. Number 7, we have B is the midpoint here of this side, and it's a 90 degree. Well, this is a perpendicular bisector. Number 8, well, this segment AB is the leg of this right triangle right here. So that's possible that our segment, one of these segments, can actually be on the triangle. In this case, since we're going from the vertex to the opposite side forming a 90, That's the same as number 4, right? Going from the opposite vertex to the base forming a 90. This is also an altitude. All right. Let's have a look at this fill in the blank. So here are our 4 different types of centers that we've been discussing. So let's match them. So triangle A, point P is called the, okay, so what's happening here? We have this point here. So let's identify what these segments are doing. This segment right here, what's happening? It's going from the midpoint to the opposite vertex. Well, this is a median, this segment. These segments are all medians right here. That's a median. So where do the medians intersect? They intersect at the centroid. Centroid is also where we have the center of gravity of the triangle. Okay, what kind of segments are these right here? This segment right here, what is this? Well, what do these symbols right here mean? Remember, I can also put hashes on, mean the same thing. These are angle bisectors, right? These segments. So where do the angle bisectors meet? They meet at the in center, and from the in center we can inscribe a circle. Right, so if I wanted, I could pop a circle right in here, and that is the special property of in-center. What's happening with this one? Let's take a look at this segment. We're going from the vertex to the opposite base, forming a 90 degree. Well, this is an altitude. And where all the altitudes intersect is called the orthocenter. You know, in process of elimination, we'd say, okay, we've done everything but the perpendicular bisector, is what this is, and those meet in the circumcenter, where we can circumscribe, circumcenter, we can circumscribe a circle. That means the circle goes around the triangle, like that. Okay. All right, so some new parts here maybe for you guys. Graph triangle ABC here with these coordinates, and find the this one, the perpendicular bisectors and the altitudes. Okay, so we've got 0, -2 is A. I'm a big fan of labeling this stuff. 4, -2 is B. 0, 4 is C. And let's frame it up. Not with that tool. Alright, we got that. Maybe let's just color it in a little bit. And okay, so perpendicular bisectors. So I gotta find the midpoint. So the midpoint between 0, -2 and 4, -2. Well, I can see this is just 4 units long, so I'm just gonna cut it in half here. It's a horizontal line, so vertical lines are always perpendicular to horizontal lines. Let's go look at this one. I'm going from 4 to -2. That's 6 units. That's 6 units right there, right? From 4 to -2. So what's half of 6? 3. So I'm going to count 3 down from the top, or 3 up from the bottom. I reach the same place, so I'm going to put doubles on this. And this is a vertical line, so that means I need a horizontal line to be perpendicular. How about let's get some perpendicular symbols on here. And we can already see they're both intersecting here, but let's do the third one just to check. I'm going from 0, 4 to 4, negative 2. Well, how about we just bust out this midpoint formula? Just because I know some of you still have some difficulty with this concept. We take the average of the x's and the average of the y's to find the midpoint. Let's call this one x1, y1. It doesn't matter which point you label as x1, y1, x2, y2. 0 plus 4 divided by 2, those are my x's. And then 4 plus negative 2 over 2. And so my midpoint is 4 halves, comma, 2 halves, or 2, negative 1. Sorry, 2, 1. So over 2, up 1. Oh, good. That's what I was hoping it would be, right? I mean, we knew it was going to be there. We just verified. So let's put triples on this. And now we need a perpendicular line to C to B. So what is the slope? I'm going to say M. Let's put sub C, sub B right here. So from C to B. We're going from 4 down to negative 2. So that means I'm going down 6 units. That's 6 unit drop. And I'm going 4 units over to the right. So that's negative 3 halves. There's my slope. So I'm going down 3 over 2, down 3 over 2. Now I want a perpendicular slope to that. So what do? I make it negative and reciprocal. So that would be 2/3. So now from my midpoint, I go up 2 over 3. Or I can go down 2 to the left 3. And now draw my line. Boom. There it is. That's a right angle. So I think we can all agree this point is where all the perpendicular bisectors meet. We call that the circumcenter. And so let's label that point 2, 1. What can we do from the circumcenter? We can circumscribe. Just to remind you guys, that's this special characteristic of this center. Okay, so we just did A. Let's take a look at B. What is the coordinate for the point of concurrency for the altitudes? So where all the altitudes meet, we call that the orthocenter. So I could have phrased this question, where is the orthocenter? Okay, the orthocenter is where all the altitudes meet. So if we notice, this triangle here is already a right triangle, right here. So angle CAB is already, right? The measure of angle CAB is 90 degrees. So remember what we said back up here with this one? We said, wow, this is a right triangle, and the leg itself ends up being an altitude. Well, that's the situation we have here. This leg is an altitude. So I get a blue here, get my straight edge. That is an altitude. Also right here, from this vertex to the base forming a 90, that's an altitude. Look at this, they're all meeting. They're meeting right here. We've got one more we can check. So we already know that the perpendicular slope of CB, so we already know the slope of CB is right here because we just found it, right? Is negative 3 over 2. Well, we know that perpendicular slope is 2/3. So why don't we just go from A right here and just do a slope of 2/3 until we hit the base, because that would give us a 90. So up 2 over 3 is right there. I know I'm off the line, off the triangle even, but that's okay. Now I get my straight edge. I just line it up until I hit. So I could go all the way through that point, but then I'm just pulling it back to there. And then there's my altitude right there. That's a 90. So they all meet here. So my point of concurrency for altitudes, aka orthocenter, is 0, -2 is the answer for this part B. Okay? Let's take a look at this next one. Find the coordinates of the centroid in a triangle. Well, a centroid is where all of the medians intersect. All medians intersect. Let's pop up. So that was this first one right here. These are all the medians intersect. This right here is a centroid, point P. Okay, we also seen median up here in number 3. This is a median. We go from the midpoint of a side to the opposite vertex. Okay, so we already know where the points for the vertices are. We just got to find midpoints. So we're going to graph this triangle and then just find all the midpoints, and then half the work is done for us. Let's get a new color. How about plum? So -2, 4 is here. It's A. B is a -1, 1. C is 6, 3. 6, 3. And double check your points. You know, I see it's easy to switch these points, the X and the Y. But if you switch them, it's not going to work so nicely, because I'm giving you, these are intentional points. If you just use any points, you'll see you don't get nice numbers for your centers. Okay, there's the triangle, and how about let's get some honeydew on this thing. Okay. Now, we got to find medians. Okay, so a median goes from the midpoint of a side to the opposite vertex. So, tell you what, let's do a couple. Let's do 1 or 2 visual, and then one maybe do the formula. So from A to B, we are dropping 1, 2, 3, 4, 5 units, and we're going over 1 unit. So let's take half of that. So what's half of 5? Half of 5 is 2.5. So if I go down 2.5, that gets me to here. And then this one's 1, right? Well, what's half of 1? It's a half. So if I go to the half here, and we see if I trace this up and this one over, it's right here is our midpoint. Okay, right there. That's our midpoint. And then we're going to draw the segment from the midpoint to the opposite vertex. Okay? This right here, that segment, is called a median. All right, now we're going to do A to C. I'm going to do another visual method. So we're going 1, 2, 3, 4, 5, 6, 7, 8 units. So what's half of 8? 4. So that means we're going to go 1, 2, 3, 4. Here's 4 right here. Whoops. 4 is right. Sorry. 1, 2, 3, 4 is right here. And then we are dropping 1 unit. So that means a half. Half is right there. So right here is my midpoint. Let's put double hashes on that. And all we do is we go from the midpoint to the opposite vertex. Okay, so I already have an intersection right here. Looks like I might be able to just name my line right now. But I'm going to go ahead and get the last median to double check my work. So let's find the midpoint from B to C. And let's use the equation this time. x1 plus x2 over 2, y1 plus y2 over 2. We're taking the averages of the x coordinates and the y coordinates. And so let's call B the first point. So -1 plus 6 over 2. And that's a negative here too, right? -1, 1. -1 plus 3 over 2. And we get 5 halves and 2 halves. And so 5 halves is the same as 2.5, right? And 1. So I'm going over 2.5 and up 1 right there. Here's my point. Put some triple hashes on that thing. I'm going to draw it back from the median to the opposite vertex. Kind of drew that funkily here. Let's get that a little better. And here is where they all intersect. Right there, that's called the centroid. And let's identify this coordinate. We're going over 1, up 2. There's our answer. 15. Find the circumcenter using coordinate geometry. Okay, when I say that, it means don't do a construction. We could do a construction. That's a different technique. I want to use coordinate geometry. So that means finding midpoints, using perpendicular lines, etc., etc. Show all segments, angles, and congruences. Okay, circumcenter. So circumcenter, we need to find all of the angle bisectors. Sorry, perpendicular bisectors. Wrote one thing, said another. Okay, so let's find the easy one here. B to C, this horizontal line. We're going from -2 to 8. That's 10 units. From -2 to 8 is 10 units. Half of 10 is 5. So let's run 1, 2, 3, 4, 5. Boom. Put a point right there. Let's check to see there are 5 units on the other side. 1, 2, 3, 4, 5. So right here is my midpoint, and we're going to draw a vertical line because that's perpendicular to a horizontal line, and we're going to make it nice and long here. Okay, let's find our midpoint of A to B. So here I'm going down 4 and over 2. So let's take half of 4 and half of 2. So that means I will go down 2 and over 1. That is my midpoint. What is the slope from A to B? I already said it, right? Down 4 over 2. Down 4 over 2 simplifies to -2 over 1. Well, we need a perpendicular line to that segment. So that means we need to take the negative reciprocal of -2 over 1, which is 1/2. Which means from this point we're going to go up 1 over 2, up 1 over 2, up 1 over 2, and make our line. There it is. Looks like we have an intersection, but we are going to do all three as a check. Let's find the midpoint of A to C. So again, x1 plus x2 over 2. I'm going to do the equation. So we've got -4 plus 8 over 2. And we have 3 plus -1 over 2. -4 plus 8 is 4. Divided by 2 is 2. 3 plus -1 is 2. Divided by 2 is 1. 2, 1. Right there. Triples, that's our midpoint. Okay, what is the slope from A to C? Well, it looks like we're going down 1 over 3, doesn't it? Down 1 over 3, down 1 over 3, down 1 over 3, down 1 over 3. We need the perpendicular slope to that, which is 3 over 1. So now I'm going to go from this midpoint and go up 3 over 1, up 3 over 1. And we've verified that these three now are intersecting right there. That's the circumcenter, and that point is 3, 4. Let me put my right angles here. I already have my congruent symbols. And I can circumscribe a circle from this point. Cool. There it is. Last one. Find the orthocenter using coordinate geometry. All right, so we're going to go from a vertex to the opposite base, forming a 90. Okay, so we're making altitudes, right? Altitudes. We're going to find 3 of them. So let's start at A. We got to make, so BC here, the base, is horizontal. So that means if we go, let's get green here. If we make a vertical line from A until we hit the base, whoa, that's not a segment. We are going to get our first altitude right there. That's 90 degrees. So that one was easy. Let's go from point B to its opposite side. So how do we make the segment so it intersects this opposite side at a 90? Well, we need to identify the slope from A to C. And if we see, it looks like we're going down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. We are going down 1 over 1. Well, what is the perpendicular slope of that? Well, we change the sign and take the reciprocal. It's just 1 over 1. So go to B now, and we're going to go up 1 over 1, up 1 over 1, until we hit our opposite side. This is a 90 right here. Okay, it doesn't bisect. This is not a midpoint. That's something else. So we have one more to do just to verify our intersection here. And we're going to go from C to side AB. Now we should check the slope from B to A so then we can find the perpendicular slope. So I'm going up, looks like 4 over 1. I'm going up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Okay, so our slope is 4. Or I can say 4 over 1 because the perpendicular to that is going to be negative 1/4. So from C, we're going to go down 1 over 4, but I'm going in the wrong direction. So instead of going down 1 over 4, I can go up 1 to the left 4. 1, 2, 3, 4. Up 1 to the left. 1, 2, 3, 4. Up 1 and to the left. 1, 2, 3, 4. Right there. Doesn't matter that I'm off the line, off the triangle. I'm just need to line it up for my slope, but then I'm going to back this down until it hits the line right there. Maybe I should have done this in green. That is my last altitude, and they all intersect right here, which is the orthocenter. And let's label it. It is at 0, 1. Okay, very good. I think, yep, that's it. That was the last one. Look, I hope you guys see there's a process here. I'm showing work, right? I'm not just giving answers. All right? I don't just give answers for you and expect you to understand what I'm doing. So don't just give single answers without work to me, because then how do I know what you are doing? So give me some work. Show me some of your evidence, your proof, etc. Hope this makes sense. Tomorrow we'll do some more challenge constructions and go on from there. All right, have a good one.